Under laws of motion, today I am going to explain the last part, that is gravitation. Now, as you all know that in the universe, not only in the universe, in fact on the earth as well, now two objects, they in fact exert a force of attraction on each other. But only thing, it is not noticed by us because we are very close to each other, and when you compare the size of the earth with our size, the mass of the earth with our mass, in fact it is negligible. But remember, always between two objects there is always a force of attraction present. Alright? Now Newton observed this in case of heavenly objects and even with objects which are present on the surface of the earth, and he stated a law which is called as law of gravitation. Now suppose there are two objects present, object 1 and object 2. They are separated by a distance r. The distance of separation is r, and mass of this is m1 and m2. So it was observed that the force of between both the objects is directly proportional to the product of their masses. So I can write F to be directly proportional to m1, m2. And this same force of attraction, is inversely proportional to the square of the distance between them. So it is found to be inversely proportional to 1 upon r square, where r is the distance of separation between both the objects. So when I combine this, I get F equal to m1 m2 upon r square. Proportional to m1 m2 upon r square. So when I remove this proportionality sign and introduce a constant, I can write it as force is equal to G times m1 m2 upon r square, where this G is a constant value and it is called as gravitational constant, and it is also called as universal gravitational constant because it is having a fixed value. So if I write it in terms of G will be equal to r square times F upon m1 m2. So now I am going to derive the unit of this gravitational constant. Now G is r square F upon m1 m2. So I am going to write a unit. Now r is distance, so I can write it in terms of meter square. Then you have unit of forces Newton, and you have product of masses in terms of kg square. So which can be written as Newton meter square per kg square. Now this is the unit of gravitational constant. And what is the value of this gravitational constant? As I have already said, it's a fixed value and it is given by G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. It's a fixed value. Now, knowing this, now I'll just quickly tell you about the characteristics of this gravitational force. Characteristics of gravitational force. Now, it is an attractive force. First thing, it is an attractive force. It is more significant as far as heavenly bodies are concerned. Because of their massive mass, it is more significant there. And then you find you can say it is directly proportional to the product of masses, this force of attraction. Alright? And it is As the distance of separation increases, you find the force of attraction decreases. So these are 4 observations which are made regarding this force of attraction, regarding this force, gravitational force. Correct? Now, this law of gravitation, what is its significance? Now, this law of gravitation is used to study the motion of the planets, motion of the of any heavenly body is being studied using this law of gravitation. Now, I'm going to explain about force due to gravity on a mass, 1 kg mass, which is present at a certain distance from the Earth. Alright, suppose it is kept on the surface of the Earth, for example. So now let's see what is the force due to gravity. If capital N is the mass of the Earth, you have R as the radius of the Earth, and small n is the mass of the object, that is 1 kg mass. Right? Now, what is the formula to find the force due to gravity? F is equal to gravitational constant times small m is mass of the smaller object, capital M is the mass of the Earth, upon distance between square of the radius. That means here we have to consider the radius of the Earth, because the object 1 kg mass is placed on the surface of the Earth. Right? So when you substitute the values, you are going to get F is equal to, the value of G is 6.67 into 10 to the power of minus 11 multiplied by small m is 1 multiplied by mass of the Earth is 5.96 into 10 to the power of 24 divided by square of the radius 6.37 into 10 to the power of 6 the whole square. So when you solve this, after solving this, you are going to get the answer to be 9.8 newtons. That means force of attraction. So this means a 1 kg mass gets attracted by the Earth with a force of 9.8 newtons. Correct? This is the force that is being exerted. Now I am going to explain about acceleration due to, once you know the force, let me talk about acceleration due to gravity. Next is about acceleration due to gravity. Now, so far we have learned about force exerted between two objects. Now, acceleration due to gravity is nothing but the acceleration that is produced in an object due to the force of gravity which is present on the Earth. Acceleration of any object. Correct? Now here, in fact, it is denoted by the letter G, and its value is equal to 9.8 meters per second square. So that means any object is being accelerated towards the Earth at the rate of 9.8 meters per second square. Correct? Now, Galileo was the first one to observe that when two objects of different masses, when they are released from the same height and at the same time, they reach the Earth at the same time. So that in fact is called an acceleration due to, so it is due to this acceleration that these objects are able to reach the ground. It is due to the gravity of the Earth. And that value is 9.8 meters per second square. It is a vector quantity. It is a vector quantity, and it is also observed that this value of G is not same throughout on the Earth from places. If you are comparing equator with that of the poles, you find the value of G will be different. On the poles, the value of G will be slightly higher as compared to that on the equator. Right? So, How do you define this acceleration due to gravity? It is the acceleration produced in an object when it is released from a certain height due to the force of gravity. Correct? And on the surface of the earth it is maximum. As you go higher and higher, you find value of g decreases, and as you go towards the center of the earth also, the value of g keeps on decreasing. Correct? Okay, now we come to the relationship between small g, that is acceleration due to gravity, and g. Now, you know that force acting on an object is nothing but it's the product of mass and acceleration due to gravity, that is mg. And the value of g is given by, now you know that F is given by g times small m upon r square. So when you combine both, I can write it in terms of g. So when I combine, I'm going to get mg is equal to gm upon r square. Correct? So I can cancel m and n. So I get small g is equal to gn upon r square. So this is in fact the relationship between acceleration due to gravity and gravitational constant. They are related by g equals. So acceleration due to gravity depends on the, other than the gravitational constant, it depends on the mass and square of the distance between the two objects which are under consideration. Correct? The next concept is about using equations of motion. Now let us see how these equations of motion get affected when an object is freely falling. For free fall of an object, then when initial velocity is 0 and when acceleration is g. Now let's learn in a free fall when an object is falling freely. Suppose its initial velocity is 0, how will these equations of motion change? Now I'm going to write the equations of motion. Ut plus at s is equal to ut plus half at square. V square is equal to u square plus 2as. Now these are the equations of motion. Now in a free fall, when initial velocity u is equal to 0 and a is replaced by g, a is equal to g. So these equations will change to v equals gt, s is equal to half gt square and v square is equal to 2gs. Now these equations are true when you have initial velocity at 0 and a is replaced by g. Now if an object is released in such a way that it is having certain initial velocity, then you find these equations can be written as v equals u plus gt, s is equal to ut plus half gt square and v square is equal to u square plus 2gs. And this is true when there is certain initial velocity involved. And suppose the object is thrown vertically upwards. That time you find the value of g becomes negative. Now in that case you have v is equal to when g is negative, right? So you have u minus gt, s is equal to ut minus gt square half and v V square is equal to U square minus 2GS. So accordingly these equations of motion will change. Correct? And the next concept is about mass and weight. Now let's see how mass is different from weight and about its unit. Now mass of an object is in fact how much of matter is present in a particular substance is the mass of an object. Mass does not change from place to place. It remains constant. Wherever you go, you find the mass of an object will not change, as it is the intrinsic property of that particular object. It is denoted by small m and its unit is in kgs. Unit is kgs. It does not change from place to place. Whereas weight of an object is nothing but the force with which that object is pulled towards the earth. It could be the earth or any other planet. So F is given by the product of weight of an object is given by W, that is weight of an object is given by the product of mass and the acceleration due to gravity. So it is mg. Again, you can write it in terms of newtons. Its unit will be newtons. Now weight will change from place to place. It will not be the same all over the earth, or if you go on some other planet also, you find the weight of a person or for that matter any object will not remain the same. As g value will be different on different planets, and if it is on the earth itself, as I have already said, the value of g varies from place to place. On the equator, g value will be less, and on the poles you find g value will be more. So accordingly the weight will vary. Now we come to the gravitational unit of weight. Now 1 kilogram of force is equal to 9.8 newtons, and 1 gram of force is given by 980 dynes. So this is the relation in terms of gravitational units of force. Okay, so these are the gravitational, and for normal it is in terms of kgs, and weight also again is in terms of newtons. Okay, so when I say I'm talking about 1 kilogram of force, it is in fact like when you have on your palm, when you place 1 kilogram of weight of an object is nothing but you can say the pull with which that weight is the weight is pulled towards the earth. So that is 1 kilogram of force, which is in fact 9.8 newtons. Right? I think with this we are finishing with this part, that is gravitation. Right? Thank you.